Hello, this is the first video on quadratic equations. I'm going to start by looking at linear graphs, then we'll look at quadratic graphs and try to motivate why we might want to solve quadratic equations and a good method for trying to solve them. So first of all, let's look at this linear graph. So this is y equals 3x add 2. So just a very brief reminder, anything where you've got y equals and then it's something x plus something, this is going to be a linear graph, okay? Every time you increase x by 1, then if I made x be 1 bigger, then this expression here would become 3 bigger. So whenever you go 1 along in the x direction, you go 3 up in the y direction. So for example, if you make x be 2, you'd have 3 times 2 is 6, add 2 is 8. So I'm just going to write this down. If x is 2, then y would be 8. And if I make x be 1 bigger than that, so if x was 3, we should expect that y will be 3 more. So 3 times 3 is 9, add 2 is 11. And this would happen in general, okay? And you can actually prove it in general. Because if you place x with x plus 1, then this expression here will become 3x plus 5. And therefore, y itself has become 3 bigger. But let's not get bogged down in that. Another thing to try to revise and remember about is it goes through plus 2, because if you make x be 0, you're on the y-axis. So these are all the coordinates where x is 0. So you've got 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. 0, 2 is this coordinate here, and that's where this graph goes through, because when you make x be 0, y will be 2. So the question that we're going to start with is actually, what is this coordinate here? What is this coordinate here? And to answer that, I'm actually going to look at this coordinate again. Now I know we can see that it's 2, and we can even see maybe from this equation why it should be 2. Let's just see what we do to actually answer this and then apply it to this, okay? So here we're on the y-axis, and on the y-axis x is 0. Okay, x is 0. So I know it might seem like that's the wrong way round, right? I'm talking about the y-axis and now I'm talking about x being 0. But if you actually think about it, if you think about the coordinates on the y-axis, there, as I just said before, they're all the coordinates where x is 0. So I'll say it again. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, minus 1, 0, minus 1.5. They all have something in common. They all have the x number being 0. They all have the x number being 0, and that's our y-axis. And that's actually what we're going to use in this equation here to figure out where it crosses the y-axis. So we know our straight line is y equals 3x add 2. And so if we're on the y-axis, x is actually 0, so y will be 3 times 0, and then add 2. And if you figure this out, use BIDMAS, 3 zeros is nothing, and then plus 2 is 2. And you, of course, get 2, right? We already know that. We already know that. Now, the idea on the x-axis, there's a bit of symmetry. Because on the x-axis, it's y that equals 0. So let's have a look at all the coordinates on the x-axis. You've got 0, 0, 1, 0, 2, 0, 3, 0, 3.5, 0, 4, 0. On the x-axis, it's y that's 0. So I'm going to write that down, and you might want to make a note of that yourself, because this is going to be very, very important. Really important to so many things in maths. On the x-axis, it's y that's 0. Okay? It's like what I wrote over here, but the other way around. So on the x-axis, it's actually y that's 0. So let's write down our equation again. Y is 3x add 2. But this time, I'm not making x be 0 because I'm not on the y-axis. I'm on the x-axis, which means it's y that's 0. So I write 0 equals 3x add 2. And this is now an example of a linear equation, right? We have to solve this. It's not too difficult to solve, okay? So I'll take away 2. and I'll divide by 3. So I actually get that it's minus 2/3, which if you look there, it does look about right. Okay, it's minus 2/3. So this coordinate here is minus 2/3, 0. Okay, the x-intercept is minus 2/3 for this particular graph. Okay, and we work that out by making y be 0 this time. So I'll do a couple more examples and I'll do them quickly, and then we'll talk about the quadratic situation. So y equals 2x minus 4. Now if you didn't have the graph, so imagine the graph wasn't there, and I asked you where does this cross the y-axis and where does this cross the x-axis, you'd have a bit of work to do. Now clearly, since we've got the graph in front of us, we can just look. The y-intercept is minus 4, which makes a bit of sense, right? And the x-intercept is 2. Now let's see if we can really convince ourselves that this should be the case. So for the y-intercept, it's x that's 0. X is 0 on the y-axis. X is 0, so I'm going to have y is 2 lots of 0 take away 4, which is minus 4, right? And that's what we can see. We can visually see that because we've got the graph already drawn for us. For the x-intercept, there is a little bit more work to do. There is a little bit more work, but it's not too bad because it's linear. Linear is supposed to be fairly easy in comparison, right? This is about as low level as it can be when we're combining algebra with graphs. So y is 0, so I'm going to have 0 is 2x minus 4, and now okay, you add 4 to both sides, you divide by 2, and so this is x will be 2, which because 4 divided by 2 is 2, and so that's what we get there. Okay, so that's that one. And then last one before I talk about quadratics is y equals minus 3x add 1. So for the y-intercept, and this I'm doing this each time so that you get used to the approach, you get used to the method. So for the y-intercept, x is 0. Yes, okay, I know it's plus 1. I can also see it's plus 1, but I'm just showing you this so we get used to it. Clearly, in practice, you can be a bit faster and not necessarily write all of this down. When x is 0, you have y is minus 3 lots of 0 plus 1. Well, minus 0 lots of anything is 0, so it's just y equals 1. Right, which is what we can see there. We can visually see it. Now for the x-intercept, it's a number here, and we're going to try to figure out what it is. So for the x-intercept, we're on the x-axis. So on the x-axis, y is 0. So this is really what you need to get clear in your head, okay? You need to get it the right way around. You need to be able to consistently remember this. On the y-axis, x is 0. On the x-axis, y is 0. So y is 0. So 0 equals minus 3x add 1. I'm just directly substituting it into here. So in this situation, I guess I will probably add 3x to both sides to get started, so I don't have any negatives anymore. And then I divide by 3 to get x is a third. So this number here is actually 1/3. It also kind of looks like it, but we've also shown it for sure. Okay, right. So that's the linear situation. When we're working out the x-intercept, where it crosses the x-axis, we are making y equals 0, and then we are solving an equation. If it's linear, a straight line, you get a linear equation. If it's quadratic, you're going to end up with a quadratic equation, which is what this video is all about. So, first of all, let's look at the y-intercept for this graph here. So this is y equals x squared minus x minus 12. So the sort of work that you've done so far is you would draw out a little table and you would plot, you would write minus 3, minus 2, minus 1, 0, 1, 2, 3, blah, blah, blah. You'd work out the y coordinates and then you'd plot them and you join them up with a smooth curve, right? This type of curve here is called a parabola. So this actual shape, the shape is called a parabola, which is an interesting word. That's the sort of shape you get when you sketch a quadratic equation like this, right? In any case, what's the y-intercept? So for a y-intercept, it's x that's 0. So y will be 0 squared minus 0 minus 12, which is just minus 12. Now, is that what we think it should be? Ah, yes, if you look closely, it crosses here at minus 12. Okay, so that's great. That's what we want. Now, for the x-intercept, and yes, okay, I can see the x-intercepts are minus 3 and 4. I can see them visually because I have the graph. But later on in this video, and also something you need to be able to do, and what I'm about to teach you how to do, is work this minus 3 and this 4 out without me giving you the graph. And without even really drawing the graph, without you making a table of values. You know, if I just give you y equals x squared minus 2x minus 3, or x squared plus 6x plus 8, or even more tricky, y equals 2x squared plus 5x minus 3, if I say where does this cross the, well, if I say where does it cross the y-axis, that's quite easy, right? You just look for this last number, because the x's will be 0 and everything there will be 0, so you'll just be left with that. But if I ask you where does it cross the x-axis, there's some work to do because it's y that will be 0, and then you actually need to know how to solve an equation like this. So this is what I'm going to show you. Okay? So for the x-intercept, let's remember the general strategy. X-intercept is when y is 0. Y is 0. So I'm going to write 0 equals x squared minus x minus 12. And then I will just say right now, normally when you're writing down a quadratic equation and solving a quadratic equation, normally you write this bit here on the left-hand side and you make it equal 0. Okay, so I am just going to quickly do that. I'm going to write x squared minus x minus 12 equals 0. And then this here, I'm going to put a box around it, is kind of like the format that we want a quadratic equation written in. Okay, we want it to be a quadratic equals 0. Now, as it happens, we know the answers already because we've got the graph here. We know 4 solves this, and we know minus 3 also solves this. We could even check that out. If you do 4 squared, you get 16. And if you take away 4, you get 12. And if you take away 12, you get 0. So certainly 4 works. Does minus 3 also work? Well, it should do. Let's try. Minus 3, when you square it, you get positive 9. Take away minus 3, when you take away a negative, you go up the number line. So this is now 9 add 3, which is 12. Take away 12 is 0. So okay, minus 3 also works. But imagine you didn't have the graph. And imagine you didn't, you know, because sometimes the answers can be really horrible. You can't just guess them with trial and error. Where do we actually get the minus 3 and the 4 from? So this is the method. This is how you do it. You simply factorize. You factorize this. And we'll see where something close to minus 3 and 4 come from. So if you factorize this, double bracket. So the key step basically is to factorize. It's why you get taught how to factorize a quadratic. It's why you get taught how to do it, so that you can solve quadratic equations. So it's got to be x times x to give the x squared. And then these numbers here have to times to make minus 12 and add up to make minus 1. So that's minus 4 and 3. So if I put minus 4 and 3, this is the same equation. I've not changed anything about the equation. I've just changed how this expression is written. I've factorized it. If you expand this back out, you will get this. So there's nothing actually changed here. But when it's written like this, it's really, really useful. Really useful. Because it lets you work these coordinates out here. What we have here is we have two brackets, which is really like something multiplied by something else. So whatever x is, and to begin with, by the way, we're not worried about this equals 0. X can just be anything, and you plot this graph out. This is something times something else. Now, if that equals 0, then how do you get 0 when you times two numbers together? What does at least one of the numbers have to be? So one of the numbers needs to be 0 in order to end up with a product equaling 0. It needs to be 0 times something equals 0, or it needs to be something times 0 is 0. The point is either x minus 4 is 0, right? It's either this thing that's 0, this bracket, or x plus 3 is 0. Yeah, because if it's not x minus 4 that's 0, it would need to be this thing that's 0. Because when I'm timesing them both together, I get the answer of 0. And the only way that happens is if one of the numbers in the product is equal to 0. You couldn't have them both be positive or both be negative. You'd need one of them to be 0. So in any case, can you see now where our intercepts come from, where these answers come from? If x minus 4 is 0, then x would have to be 4. Right? So if I've kind of run out of space. Let me just continue it here. So I'm going to continue it here. So I'm going to have x equals 4, or if x plus 3 is 0, x would have to be minus 3. So there are two possible solutions. And what that kind of relates to is the fact that it crosses the x-axis in two places. Right, there's a place here where x is minus 3, so that's that one. That's this one here. And there's also this one here. It has two solutions. Now that's okay. A quadratic can have two solutions. Very often it will. Sometimes it will have one solution, and sometimes it will actually have no solutions. Now I will just very briefly say when this happens. So basically, you know from your work on quadratic graphs that when you plot a quadratic graph, it could hit the x-axis in two places, like this one. It could hit the x-axis in, say, one place, like this one here that I've got a picture of. And it could potentially be a parabola, one of these U shapes, that's actually above the x-axis and doesn't cross the x-axis at all. Now that would mean that you would actually have no solutions to that quadratic equation. So anyway, I'm going to do a couple more examples. So the next one is x squared plus x minus 2. So okay, we can visually see what the answers are going to be, but let's convince ourselves by doing some algebra. So we'll very quickly do the y-intercept. So for the y-intercept, x is 0, and therefore y would be minus 2. So that was quite quick. For the x-intercept, there's a little bit more work to do. Okay, for the x-intercept, there's a little bit more work to do. So we have to make y be 0. So I'm going to write x squared plus x minus 2 equals 0. And now just to kind of highlight this again, this here is your quadratic equation. That's your quadratic equation. Now, you could be presented with this quadratic equation totally separate to any graph. Okay, so what I mean is we could get rid of all of this, and I could just ask you, what is the solution to this equation? What is the solution to it? Well, let's have a look. Let me, what did I do? Let's do that. Let's copy that. Bring that back. That's what I want. Okay. Great. So I want to solve this equation, right? Now this is an example of a quadratic equation. You want a quadratic equation, it's obviously got a squared in it, and you want it to equal 0. So the first way you are taught how to solve a quadratic equation, which is what this video is all about, is you factorize. So not with the highlighter, with the pen. So bracket, 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 and then an equals 0. Now a very common thing that people will do, certainly when they're beginning and not used to this, is they will forget about this equals 0. So what they tend to do is they tend to just write the double bracket and then forget that they're solving an equation. It's really important to realize that you're taking this equation and just writing it again. So it's still got the equals 0. But when I say writing it again, I am doing something to it. I'm just changing the form of how this is presented. Okay, instead of expanded, I'm going to factorize it. So anyway, x, it's got a times to make -2 and add to make 1. So I guess that's -1 and +2. So then it's either this thing equals 0 or it's this thing that equals 0, right? Because it's got to be something times something giving 0. So either x plus 2 is 0 or x minus 1 is 0. Well, if x plus 2 is 0, that would make x be -2. Or x would be, so something take away 1 is 0, well x would obviously have to be 1. So let's just check our picture. Are the x-intercept -2 and 1? So remember, this is where we're actually crossing the y-axis, because this was y, wasn't it? Y was 0 on the x-axis. So we've got -2 here, yes, and we've got 1 here. Okay, and then that's it. So you've got to really try hard to follow the logic here. Y is x squared plus x minus 2 is just a formula, a function. So basically, you can make x be whatever you want, and y is then whatever the answer is. Now, if you actually draw this, and what I mean is you plot a bunch of coordinates, right? You choose a value for x, you work out the value for y, you join them all up, you get a shape that looks like this. And then there's a question. There's a question that says, where does it cross the y-axis? So that's an easy question, because it's just when x is 0, so it would be -2, and you can see that there. And then there's another question which is harder. It's a harder question. The question would be, where does it cross the x-axis? So that would be when y is 0, and that puts a restriction on what x is. X couldn't be anything anymore, because now it has to basically solve an equation where y is 0. So it's actually got to solve this equation here, which is a quadratic equation, and the method for solving that is you want to factorize your quadratic and then say something about the factor pair, basically. So it's x plus 2 and x minus 1, and if it has to equal 0, then you're in business, because you can actually say something about what one of these has to be. Right? One of them has to be 0, and if it's not that one, then it could be the other one, just where you get your two solutions from. Right, I'm going to do a couple more, but please feel free to obviously pause the video, come back to it, or just stop. Like if you're confident, I am going to do a couple more, and I'll go through them a bit quicker. So basically, I'm just going to solve. So first of all, okay, where does this cross the y-axis? It crosses it at +9. So if I move this out of the way, you can actually see it's at 9 there. And we want to see that this actually just has the one solution, because as you can see, it just touches the x-axis in one place, touches it at 3. So how does that manifest itself as a solution to the quadratic equation? Well, let's have a look. So x squared minus 6x plus 9 is 0. So here's your quadratic equation. We want to factorize this. So we've got x and x. We want to times to make positive 9 and add up to make minus 6. Well, that's x minus 3 and x minus 3, right? Because minus 3 and minus 3 add up to make minus 6. And minus 3 times minus 3 times to make 9. So x minus 3 is 0, or x minus 3 is 0. So x is 3, or x is 3. And yes, okay, I'm wasting a bit of time there, because as you can see straight away, we've actually got something called a repeated root. So yeah, these numbers here, these answers, are actually called roots of the equation. I'll talk more about that when I actually see you in school. It doesn't mean the same thing as square root or cube root or anything like that. Basically, anything that forces something to equal 0 is a root of that thing. Maybe I shouldn't have mentioned that, but it's just this very natural language for me to say, so I just thought I would maybe mention it there, but don't worry too much about it, it's not that important. So basically, you've got a repeated solution, we'll say. You've got a repeated solution of x is 3, okay? And how that manifests itself in the graph is it just touches the graph. It just touches the x-axis in this one place here, just at 3. So yeah, that's that. You could also have written this as x minus 3 all squared is 0. You see that? This is a bracket getting squared because it's timesing by itself. Now you can actually square root both sides without anything going wrong, because the square root of 0 is just 0. So I can square root both sides, and I can write x minus 3 is 0, and therefore x is 3. And that's your one and only solution. If you want to say that you could take the negative square root, well, that also works, but you end up with the same solution, because minus x plus 3 is 0 also gives you that x is 3. So no matter which way you want to think about it, you get one solution to this one. And how that kind of presents itself within the question is you actually get the same bracket written twice. Right, last one I'm going to do before I ask you to do some questions. So y equals x squared minus 16. So first of all, it's crossing down here at minus 16. And okay, we can see minus 4 and plus 4. So where do the minus 4 and the plus 4 come from? Well, I'm going to solve x squared minus 16 equals 0. So the reason I'm going to solve this is, to be on the x-axis, I want y to be 0. So I'm going to remind you once more about the logic here. On the x-axis, y is 0. But for this graph, y is actually x squared minus 16. Now, if I'm on about being on the x-axis, whereabouts it crosses the x-axis, I would have to make y be 0, because I'm on the x-axis. And that's actually what I started by writing, isn't it? I actually started by writing that. So when you see a question like this, maybe presented away from a graph, I want you to bear in mind that it does relate to a graph where it would cross the x-axis. Okay, you know, if you replace this with y, then you're going to have yourself a graph, and then okay, you remember that it actually said 0, so you're on about where it crosses it at the x-axis. Okay, so anyway, x squared would be 16. So there's actually two good ways of solving this. I'll show you the quick way. So x squared is 16, and then x would be the square root of 16, but it could also be the negative square root of 16, because when you square a negative, you get a positive. So the way I write this is plus or minus 4, okay? That's because if you square minus 4, you get 16, and if you square 4, you get 16. So either minus 4 or plus 4, or plus or minus 4, solve this equation. So x is plus or minus 4, so there's the plus 4, there's the minus 4. A lot of you are quite good now at actually factorizing the difference of two squares. You could factorize this as x minus 4, x plus 4, Remember, it's still equaling 0, and then you get the same answer. You get x is 4, or you get x is minus 4. It's the same thing. That's what this plus or minus symbol means. Just means it helps you quickly write the answer to a question like this, basically. Right. Okay. So your first question is solve y equals x squared minus 2x minus 3. So I'll pause the video, and then what I'm going to do is assume you've paused it, and then I'm going to go through the answer. I'll give you a couple of seconds. Right, here's me going through the answer. So I'm going to write, ooh, my apologies, guys. Didn't even ask you a question. Solve y equals x, that's crazy. Solve x squared minus 2x minus 3 equals 0. That's what I meant to say. I can imagine that some people may have paused and were really wondering what I was on about. Okay, right. Now pause and try this. Right, now I actually can go through this. So we're going to factorize. I guess that's what? Minus 3 and plus 1. Because 1 minus 3 is minus 2, and 1 times minus 3 is minus 3. So you should have x is minus 1 or x is 3. So those are your two answers. Now if I show you what the graph looks like, let me just steal it from here and show you. This is the graph. This is this graph here. Okay, so okay, it crosses the y-axis at minus 3, which is what we think. There it is, minus 3. And it crosses the x-axis at our two solutions that we actually just found, minus 1 and 3. So well done if you got that. Okay, question 2, and I'll actually ask you it properly this time. I want you to solve x squared plus 6x plus 8 equals 0. I'll give you a couple of seconds to pause and have a go, and then you can see the answer. Right, I'm going to factorize this. Make sure you dock yourself a mark, by the way, if you aren't writing the equals 0. Okay, this is still an equation. An equation will have an equals sign. Okay, otherwise it's not an equation. So anyway, it's got a times to make 8 and add up to make 6. So for me, that's plus 4 plus 2. Remember, if you'd written x plus 2 and x plus 4, it's the same because it's a product. It doesn't matter what order you times in. So anyway, x plus 4 is 0, or x plus 2 is 0. So x would have to be minus 4, or x would have to be minus 2. So here are your two solutions. Now let me show you how that manifests itself on the graph. It's plus 6 plus 8, so plus 6x plus 8 there, x squared plus 6x plus 8. So it crosses at 8 on the y-axis, so that's what we expect. And then we've got x is minus 4 there, and we've got x is minus 2 there, and there you go, job done. Right, last one. I would like you to solve, so this is question 3, and then there'll be some Hegarty tasks set, but this is probably going to take most of the lesson, including watching, right, because it's a long video, so don't worry too much. You might have a go at Hegarty, and then we'll do some more tomorrow. It's not a big deal. So anyway, I'd like you to pause the video and have a go at this. Right, hopefully you've done it. Hopefully you know, because you can check your answers, right? You take your answers, you substitute them back, and you check you get 0. Okay, so you can also check your answers. Anyway, how do you solve this? Well, you're going to need a double bracket, and we're going to need, how are we going to get 2x squared? Well, we'll need 2x and we'll need x. And then how are we going to get minus 3? Well, the numbers could be minus 3 and 1, or 3 and minus 1, or minus 1 and 3, or 1 and minus 3, right? These are our possible ways we could fit the numbers in here to get the minus 3. Yeah, if there was a -3 there and a 1 there, they times and make -3, it would work. Any of these 4 pairs would give you -3. Now, only one out of this list of 4 is actually going to work overall because we need to make sure we're getting plus 5x. So let's just see which one works. So I'm just going to show you this kind of a long-winded way. You could try to do this in your head or just try to do it a bit faster. I'm just going to show you how you can check, right? 2x times 1, so if I do 2x times 1, that's 2x, and then -3x would be -x. So that's not 5x, so that doesn't work. So it's not this first one. Okay, we have done quite a bit of practice of this in school, by the way. Although I appreciate a lot of you probably haven't done it for a while. So anyway, +3 minus 1. Let's see if this one works. 3x minus 2x is plus x, so that doesn't work. If I'm doing that too fast, I'll just show you what I'm doing. I'm doing 2x times the -1. That would be minus 2x, and then 3 times x is 3x. And when I add them up to simplify, I don't get 5x, which means that it's not this either. So let's try -1 and +3. Now already this looks like it's probably correct, doesn't it? Because 2x times 3 is 6x. Minus 1x would be plus 5x. So it's this solution here. So there we go. Except we're not quite done. We're not quite done. Before, you know, when you were just learning to factorize, this would have been your final answer. But this is not your final answer here. We actually want to know what are the solutions to this equation. So there's going to be 2 solutions, right? We either have this bracket, which is 2x minus 1 equaling 0, or we have this bracket, which is x plus 3 equaling 0. So it's these 2 possibilities, right? It could be this being 0, and then it wouldn't matter what this was, because we would get 0 and it would be fine. Or this could be 0 and it wouldn't matter what this was, because again, you times make 0, which is what you want. So anyway, you get 2x is 1, or x is a half, or this one's a bit easier, this is just x is minus 3. So your 2 solutions are x is a half and x is minus 3. And that's it. Don't even need to talk about the graph, although I will show you what the graph of this looks like, so you can see again how it manifests itself in the graph, these 2 solutions, right? So okay, we already said this crosses at -3 on the y-axis, so there you go. There's your y-intercept. Yeah, remember how we get that? That's when x is 0. And when x is 0, you're left with -3. We have 2 x-intercepts, and these occur when y is 0. So your x-intercepts are when y is 0. Now when y is 0, we've actually just solved it. You get x is a half, which is this one here, and -3. So there you go, x is also -3. Right, I hope you've learned something from this video. I know it was a bit of a long one, but it was supposed to like occupy a lesson. With you doing some of the work and making notes and, you know, listening and stuff, this video is the lesson, okay? You can look on Heggerty, and I have set you some tasks, but that's only because there might have been some people who finished this really quickly or didn't watch the whole thing or whatever, okay? But hopefully you're now in a position where you could begin to solve quadratic equations. Just a final recap, you want to make sure the quadratic equation equals 0. Okay, that's a really key point, because sometimes they'll start off by equaling something else, and you want to shift everything over to the left-hand side so that it equals 0. Then you factorize, and then you say something about each of the 2 factors, right? Because one of them has to equal 0, or the other one does, and so that's where your 2 solutions come from. Okay, so any questions you ask on Teams or you ask via email. And yeah, this is what we're going to be doing for a few lessons. Feel free to rewatch the video or write down things that you want to ask or whatever. Hope it was useful. See you later.